Welcome back to The Explainer. Look, mastering exam strategy is exactly like professional photography. You can have the most expensive camera in the world, just like you could have memorized the entire Cambridge textbook. But if you don't know how to find the perfect angle, if you can't frame your subject to highlight the absolute key evidence, your photo or your exam answer is going to fall completely flat. Today, we are cracking the code on a truly vital part of your Cambridge computer science exams: utility software, specifically file compression and backup software. Whether you're taking syllabus 0417, 0478, 0983, 0984, 2210, or 9618, this strategy applies. I want you to picture two types of students. Let's call them Alex and Sam. We see them all the time when reviewing past papers, like the classic 9713 series. Alex is the data dumper. Alex overloads every answer with raw computer science facts, but provides zero analysis. Then there's Sam. Sam is always rushing. Sam completely misses the command word requirements and just writes whatever comes to mind first. When you look at their papers side by side, it is just a sea of red pen marks from the examiner. Today, we're going to fix that. We are deconstructing the examiner reports to give you the ultimate blueprint for framing your answers perfectly.
Okay, let's dive right into this. Just look at that number, 15%. That is a massive chunk of your final grade. Utility software accounts for approximately 15% of the total marks in Paper 2. That means this absolutely isn't a topic you can afford to just skim over the night before. It's a goldmine. Mastering the single area, knowing exactly how to frame your answers about file compression algorithms or backup protocols can literally be the difference between moving up an entire grade boundary. You don't just want to pass, you want to extract every single available mark.
To get you there, our roadmap today has 4 distinct stops. 1. Core principles. 2. The procedural engine. 3. Critical examiner alerts. And finally, evaluative mastery.
Let's start with Section 1. Core Principles, Mastering the Foundations.
Here's the biggest secret about Cambridge exams. Examiners aren't just checking if you've memorized the textbook definition of a differential backup. They are actively targeting 3 distinct cognitive domains: knowledge, application, and analysis. This is where command words come into play. If the command word is describe, they want knowledge. If it's apply, they want you to map a concept, like run length encoding, to a brand new scenario. If it's evaluate, they want deep analysis of its effectiveness compared to other methods. This is exactly where our friend Sam messes up by rushing. To beat this, you need to use the PEEL framework: point, evidence, explanation, link. You make your point about a backup system, you provide evidence from the scenario, you provide an explanation of the technical mechanics, and you link it all back to the specific question asked. So, what separates a good student from a truly phenomenal one? Top-performing candidates don't just state facts like Alex does. They map causal relationships. They don't just write, lossy compression makes files smaller. That's a zero-mark explanation. Instead, using the PEL framework, they explain exactly why discarding specific metadata reduces the data payload, which in turn increases the transmission speed across a network constraint mentioned in the prompt. It's this interconnected thinking that scores the absolute highest marks. Let's do a quick mental exercise. I'll give you 10 seconds. Imagine an answer that says incremental backups save time versus an answer that says incremental backups only copy data altered since the last backup, minimizing the read-write cycles required during the hospital's operational hours. Which one follows PO? The second one, obviously. It provides the explanation and links back to the hospital context. Before we continue, subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving right along to Section 2, the procedural engine, executing the methodology.
Algorithmic thinking for utility software requires an incredibly strict 4-step framework. You start with step-by-step decomposition, then appropriate data structure selection. Third is efficient code implementation. And finally, rigorous testing. Let's bring Alex and Sam back in for a live transformation. If they are asked to design a backup protocol, Sam tries to skip straight to writing code without decomposing the data types first. The examiners immediately notice and the marks tank. Alex writes a massive essay on every data structure known to man, but never actually selects one. Again, 0 marks. But when we guide them to rewrite their answers using these 4 steps, the red pen marks literally turn into green check marks. Why? Because identifying the components first proves to the examiner you understand the architecture of the problem before you attempt to build the solution. We call this the computer science success blueprint.
The crucial point here is understanding the stark difference between these two mindsets. Average candidates operate on a result-only mindset. They just desperately want to get the final code or the final answer right. But top-tier students, they use the method mark strategy. Listen carefully. The Cambridge syllabus heavily rewards process. Marks are awarded for your methodology, for how you selected those data structures, and for how you set up your testing protocols. Even if your final code has a minor logical bug in it, a robust methodological process captures those vital method marks along the way. You are essentially building a safety net of marks before you even reach the final conclusion.
We have now entered Section 3, Critical Examiner Alerts, the Danger Zone. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's kick off an interactive workshop right here. I want you to really think about this for a second. With 15% of the paper's marks on the line for utility software, where do you think most candidates bleed points? Is it writing bad pseudocode? Is it completely misunderstanding the different compression types? Let's do Challenge 1, the data scan. Imagine a complex data table on your exam paper detailing server loads and daily file changes for a corporation. You have 60 seconds on the clock. What are you looking for? You aren't looking for the technical terms, you are extracting the core trend. Does the data show huge daily changes or tiny ones? That core trend dictates whether you recommend a full backup or a differential one. Failing to scan and extract that specific context is exactly where the points vanish.
And that brings us to Challenge 2, Find the Flaw. Listen to this direct quote from the principal examiners. The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. This is huge. If I show you a sample paragraph that says, "A full backup copies all files to a secondary storage device to prevent data loss," can you spot the flaw? The flaw is that it is entirely generic. It's textbook Alex. If the exam question is about a global bank needing rapid recovery after a cyber attack, and you write that generic sentence without ever mentioning financial ledgers, encryption, or downtime constraints, you lose the application marks. You must contextualize every single point to the specific exam scenario.
Building on that, the examiner reports flag these top 3 mistakes year after year. Number 1, confusing cause and effect, especially when discussing the trade-offs of file compression. Number 2, forgetting to check boundary conditions and edge cases during testing. What actually happens to your compression algorithm when it encounters a file with 0 repeating characters? Does it crash? Does the file size bizarrely increase? You have to prove you tested the extremes. And number 3, providing contextless generic answers. Time for Challenge 3, speed writing. In your head, you have 30 seconds to write one perfect Peel paragraph explaining why lossy compression is bad for a text document but fine for a video stream. Point, evidence, explanation, link. Ready? Go. You'd say lossy compression discards data permanently. For a text file, losing words destroys readability. But for video streaming, dropping a few pixels per frame is unnoticeable to the human eye while vastly improving buffering times. Boom. Full marks.
Now, under intense exam pressure, instant recall is incredibly tough. You need systems. You need memory hacks. For instance, to remember backup types and their restoration speed trade-offs, think of the acronym FID. F-I-D. Full is slow to back up but fast to restore. Incremental is fast to back up but slow to restore. Differential is comfortably in the middle. Having simple, preloaded phrases like FID locked in your brain will save you precious minutes when exam anxiety hits and your brain freezes on the basic terminology. You just pull up the hack and get back to writing.
Which brings us to our final section, Section 4, Evaluative Mastery, Thinking like a Top-Tier Candidate.
Evaluating the quality of an algorithm or a utility software choice requires a deep, uncompromisingly analytical look. Top-scoring candidates demonstrate this mastery by consistently considering multiple solutions before settling on one. They heavily analyze algorithm trade-offs, specifically looking at time complexity versus space complexity. For example, they might compare the intensive CPU processing time required for a dictionary-based compression like LZ77 against the massive storage savings it generates compared to simple run length encoding. They don't just praise their chosen solution, they openly acknowledge its technical limitations. And crucially, they justify every single decision with hard, technical evidence drawn directly from the prompt. That is what evaluative thinking really looks like.
We can condense everything we've talked about today into a completely repeatable final system for your exams. I call it the DSE loop, governed by 3 unbreakable rules. Rule 1, command word decoding. You deconstruct the given information based entirely on what the command word asks for. Rule 2. Peel framework application. You solve the problem systematically, making your point, providing evidence, explaining the tech, and linking it back. Rule 3. The time management matrix. You evaluate for reasonableness and make justified recommendations without getting bogged down writing generic fluff that earns no points. This DSE loop, deconstruct, solve, evaluate, guarantees you're hitting those knowledge, application, and analysis domains perfectly every single time you put pen to paper.
I want to leave you with this provocative thought to chew on as you continue your revision. When you design your next backup algorithm or write your next exam answer, are you just loosely solving the problem, or are you engineering a response robust enough to survive the edge cases and the examiner's red pen? Remember the 15%. Frame your answers with the peel method. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.